Hey everyone, welcome back to the channel, and in this video we're continuing the generative AI and RAG series. We learned about what Gen AI is, concepts like vector databases. We learned about SingleStore using Jupyter Notebook, learned about a nice project where we basically searched all of Wikipedia for video game information, built a chatbot. If you missed that, make sure you check out the previous videos. And in this video, we're taking that a little bit further. We're going to learn about how to deploy SingleStore on Kubernetes using like cloud providers, CVO, GCP, AWS, Azure, hyperscalers, or whatever you want to call it. So we're going to look at the process of deploying a cluster in a Kubernetes environment using the SingleStore's Kubernetes Operator. And this operator, it's a powerful tool that simplifies cluster management, allowing you to easily resize clusters, replacing failing nodes, and also seamlessly upgrade to newer versions of SingleStore. And yeah, pretty straightforward stuff. We'll do that in this tutorial. If you have missed out on previous tutorials, make sure you watch those. We covered from scratch, Gen AI, RAG applications, and SingleStore is a pretty powerful platform, which you can get started for free using the links in the description below. You don't have to add a credit card or anything. And they have some amazing tutorials as well. And pretty easily, you can just click a button, have your database ready, and get that connected to your Jupyter Notebook. Why am I explaining this? If you want to learn more, check out the previous videos that I did. Those are going to be really helpful. And all of those links can be found in the description below. Some nice resources for you as well. But yeah, let's do some cloud stuff, Kubernetes stuff for Gen AI and RAG applications using SingleStore. Let's get started. All right, so for this tutorial, we'll start with a 4-node cluster, which is the recommended minimum to showcase SingleStore's capabilities as a distributed, highly available database. However, if your needs grow, the steps that we cover will allow you to scale out to additional nodes as well, boosting performance for large datasets or handling higher concurrency loads. And for this tutorial, we're going to be utilizing CVO. CVO is a cloud native service provider. You can check out the links in the description below. You can also check out other platforms as well, like the hyperscalers, and SingleStore works well with all of those. All right, so before we dive into the tutorial, let's cover some of the other prerequisites. Firstly, it's essential that you have a basic understanding of containers in Kubernetes, like familiarity with Kubernetes objects like pods and persistent volumes. And you can check out my DevOps Bootcamp playlist. As you can see, the Docker Kubernetes tutorial, almost close to 300,000 views. While we're going to touch on some use cases for operators, I highly recommend reading the CoreOS documentation for a more comprehensive explanation of what operators are and why they're beneficial. You can check out the links in the description below for all the resources. And make sare that you have a kubectl installed on your host system, as you're going to be needing that. So kubectl, I have it installed. By the way, this is a WAP terminal. It's pretty cool. You can, check if kubectl is installed. I mean, you can literally talk to the terminal using natural language. So yeah, it says kubectl is installed on your system. You can check out warp as well, and I'll leave the links to that in the description below also. Cool. Regarding your host environments, make sure that your cluster, your cluster deployments are on hosts that meet SingleStore's hardware and software prerequisites. Especially, you'll be needing to run Kubernetes versions between 1.19 and 1.30. I'm going to use CVO Cloud, as you can see on the screen. We're going to spin up a cluster here shortly, but if you're deploying on AWS, Azure, or Google Cloud, you can use SingleStore Helios for supported deployment. And deploying SingleStore via a Helm chart using the operator is not supported at this time, so keep that in mind. Also, your physical or virtual machine should have at least 4 CPUs and 8 gigabytes of RAM per machine, though it is recommended that you have 8 CPUs and 32 gigabytes of RAM for leaf nodes to align with the license unit calculations. And your system should be running a Linux kernel version 3.10 or later with either an XFS or ext4 file system. That was a mouthful. And also ensure that each single store pod can communicate with others in the same cluster over port 3306. Lastly, keep in mind that you need to have the setting allow volume expansion to true to enable easy storage size increases later on. And you can find more details about this in the Kubernetes documentation. Okay, so let's get started. I'm going to create a Kubernetes cluster here in my Civo dashboard. Launch my cluster. I'm going to call it SingleStore demo. I need minimum 4 nodes and I go to performance and medium is enough. Okay. Network default, default firewall, open for these ports. Yep. I'm going to use K3s, stable version. CNI, I'll use Cilium. Shout out to Cilium folks. I don't need anything from the marketplace. Create cluster. So your cluster should spin up in like 90 seconds, less than that. And then we can check in the, yeah, we'll have a kube config here as well. And we're going to then connect our Civo cluster to the Watt terminal, our local setup. So we can work with, we can do everything with the CLI itself. So just the terminal, the WAP terminal itself. And what else? Yeah, I think that should be it. Yeah, there's also the Civo CLI, so you can try that out as well. All right, let's get started with the demo. Here we have the kubeconfig file from Civo, so you can now directly use the WAP terminal to check that, okay, all our 4 nodes are up and running. Everything looks good. Each of these have 4 CPU cores and 16 GB of RAM. And once this is set up, like as you can see, we have the 4 nodes running. Now we can pull the SingleStore operator from the Docker Hub or the Red Hat Container Registry. If you're using the Red Hat Container Registry, you make sure that you're authenticating first with the registry service account. And I'm just going to do kubectl get pods, and you can see that we have this thing up and running. Cool. Now we're going to need some definition files to create your cluster with the operator. The first one is the SDBC rback.yaml file. That is the role-based access control manifest that generates a service account, a role, and a role binding object for use with the operator. I'm going to click on just kubectl create. So it's going to create all of these. As you can see, it created the service account, the role binding object for us to use with the operator. The second one is the custom resource definition for the meme-SQL cluster resource. This is what you can see on the screen. It basically defines the custom resource that the operator uses to generate the cluster. By adding the CRD to your cluster, it enables the creation of meme-SQL cluster objects, allowing the operator to manage and deploy your SingleStore clusters effectively. I'm going to apply, and I'm going to create this as well. So you can see my custom resource definition is also now created. Cool. The third file basically creates the operator deployment object that will spawn and manage the operator. You'll need to create this definition file, sdboperator.yaml. I'm going to create this as well. Here, ensure that the cluster ID argument matches the name of the SingleStore custom resource defined in your sdb cluster.yaml file. You can adjust this value if you need, but be sure that the cluster ID and the custom resource name match so that the operator, can correctly manage the resource. Now you can see kubectl get pods. This is up and running. Next, you can basically proceed to create your SingleStore cluster. Ensure that your license and the hashed password are updated, and then this is the YAML file. Go ahead and you can initiate your cluster creation. The cluster is going to spin up several pods, including the master pod, which will have names starting with the node SDB cluster. You can see this is created, and I'm gonna do kubectl get pods. This one is currently pending. Give it a few minutes, and I'm gonna wait till this is created. Wait till status change to 22 running. Okay, I will just wait a little bit more. Just run kubectl pods again, actually. Should be, yeah, pending. So as you can see, these are getting up just 22 seconds ago. It's going to take a few minutes, but we'll have that. So as you can see that here, we actually, we have two leaf pods and one aggregator pod, which is to be created. The operator creates two services for the client and the database user interactions. So you can see container creating, it's being running. Cool. So the first one is service means SQL cluster DDL. This is the DDL endpoint used specifically for creating tables. And the second one is the DML endpoint used for read-write operations and is load balanced across the available aggregators. Cool. Now we can see all the pods are up and running. We can move ahead and fetch the services that we did, as you can see on the screen. And the operator basically, what happened right now, what I did is that I'm showing you the services that the operator has created, including one for DDL and one for DML. To ensure that you can connect to your MySQL client, you can use the MySQL login command with the admin user and the initial hashed password as specified in your cluster YAML file. So we're going to do that. Password, secret pass. So this is what I'm doing. I'm using natural language in Warp rather than typing out the command. And Warp terminal is going to do it for me. So these services are up and running. Yeah, host name, I'm going to replace. Oh, actually, if you're using a cloud provider, you'll need to enter this external IP. And if you're on a local host, you can use the cluster IP to log in and connect to your MySQL client. And now that you can see, once you are in the MySQL client, you can create example databases and tables and start, storing some values in them. So I created a database over here called meme SQL example, and within it, tables like you can create such as departments, employees, salaries, and you can also insert data into these tables. So you can see I have the employees table created in it, and that's basically it. Your database up and running in a Civo cluster via SingleStore. Cool, and I'm verifying it as well. So I have created the tables, but I can verify, I can run a select query to check the values that are stored. I'm inserting into it. Yeah, if you want to check the data stored in the employees table or other tables, you can see 10 records are available over here. Yeah, now you can insert into salaries. As you can see, 10 records in salary. Here you can see number of count of employees. It shows 10. That looks good. That's not a problem. And see, now you can view as well all the employees. Very simple stuff. That's what I wanted to show you. And yeah, we did similar stuff before, but we did it on like using the SingleStore website. But now if you want to host it on Kubernetes or a cloud provider, pretty simple for you to do. Just need to work with the operator. But yeah, check out the links in the resources in the description below to learn more. All right, cool. So we created our cluster in a Kubernetes environment. Now there are several things that you can do to continue building your expertise with SingleStore. You can optimize your table data structure by understanding the differences between the column store and row store tables and learn where to choose, when to choose one over the other, as well as how to select a short key. You can also explore the various options available for loading data into SingleStore. ensuring seamless and efficient data integration into your cluster. Additionally, you can also start running queries using example schemas to unlock the full potential of SingleStore's powerful query capabilities. To maintain and monitor your cluster, you can configure SingleStore's native monitoring solution as well, which is designed to track and reveal cluster events over time, helping you identify trends and address any issues proactively. Finally, you can also refer to the SingleStore operator reference for detailed insights into the functions and configuration options available for the operator, giving you full control over your deployment. And yeah, you can check out other things they have to offer, spin it up on other providers that you use, check out the CVO documentation, check out the links in the description below, sign up to get your free credits to play around with SingleStore. If you haven't watched the previous videos already, we did some nice projects, some really good theory as well that we covered. It's a completely like a really good series, so you can check that out. And the playlist link can be found in the description below. Lastly, if you have any suggestions, comments, or requests for future videos, you want me to create a video on any specific topic, any specific use case, let me know in the comment section below. That's pretty much about it. Yeah, SingleStore made it pretty easy. So I'm hopeful that it's going to be straightforward for you as well. But yeah, check out the links in the description below, sign up to SingleStore, and leave a comment, like, share, subscribe, all the usual stuff. And I'll see you in the next one. Have a great day.